In this video, we are going to work through a series of Python exercises related to functions. And I've already created a file for the first exercise, which is going to be a kilometer converter function. So, exercise 1, kilometer converter function. And we're basically just going to write this function and then write a small test a small test program to make sure it works properly. So our function is going to be called, I've said that we'll call it kilometers to miles. And it will accept one argument, and that will be the kilometers that the, in this case, the user enters. So we'll just call it kilometers. We'll call it just kilometer. Colon, don't forget the colon. And notice that the by default Visual Studio Code will tab in because any statements under this will belong to this function. I could create a variable and maybe call it miles and set it equal to the kilometer that's passed in here and multiply it by 0.6214. That's going to create two steps. I'm just going to do a one-step operation here where I'm going to return the value that is passed into this function, which is the kilometer, and just multiply it directly by 0.6214. Remember that a method is a generic term for a function or a procedure, so you don't have to do this in-method thing. That's just something I like to do so that the students are very clear that this is the end of this particular function in this case. All right, let's create our main method or our main function. It's not going to accept any parameters, so it's just beginning and close parentheses. No parameters for the main function. And I'm going to go ahead down here and call the main function. Remember, we have to call the main function or the main method for our program to actually execute. If you don't include a call to the main method, the program won't do anything. It'll just zip through. Alright, so let's write the introduction or the introductory output using the print function. And I'm just going to call it this driver program. Driver programs are often used for testing purposes. In this case, we're testing a function. This driver program tests the kilometers to miles function dot and \n for the new line character to get some separation. I'm going to create an input here, and I'm just going to call it kilometers. You can call it whatever you want. And it's going to be assigned the result of the input function where we ask the user to enter a distance in kilometers, colon space. Be sure to put that colon space in there. We do want separation so that it looks better for the user and it'll be easier for the user to understand. And I'm simply going to do the calculations directly in a print statement. So I'm actually going to do an empty print function first, and then I will do kilometers. Speaking of which, I do need to convert the input here, which by default the input function returns character data or string data, and I wanted to convert it to a float. So I'll put the input function inside the float function to convert it to floating point values. So we'll output kilometers and then the word kilometers equals, and here I'm going to make a call to the function. So kilometers to miles. Notice the IntelliSense there, and if you highlight what you want, you can hit tab and it will fill it in for you. And I'm going to pass into it kilometers, and then after that, comma, and the word miles. Going to right there. I should do it. So, what's happening here? Instead of assigning the result of this function to a variable, I'm just going to call the function directly, and it can be outputted directly in the print statement. Let's run this. But before I run it, let's go over what's happening here. So when I run this, the Python interpreter will read all the way down and then hit main, because this is the first, this function is in the global scope, whereas these are in the global scope, but they're not being called until down here. So we call the main function, we jump up here, we output the program's purpose, we then ask the user to enter a distance in kilometers, we convert it to a floating point, and that value is assigned to kilometers, so we output a blank line. And then finally, we output what the user enters. We output the word kilometers equals. We then call the kilometer to miles functions, passing into this function, and this is called an argument, the value that the user entered. We hop up here. Kilometers as an argument gets pushed into the kilometer parameter. Do keep in mind that by default, Python does something called pass by value, which means the value of this argument, argument variable, will be passed into this parameter variable. So if we entered 5 here, 5 gets passed into the kilometer parameter. It's passed by value, which means only the contents of the variable is passed, not the variable itself or its memory location. Which means I now have two variables that have separate memory locations that reference the same value, that reference their own. If it was 5, then this kilometer would be 5, this kilometer would be 5. It just happens that that they have, because I passed this in as an argument to the parameter here, the values are the same. However, memory locations are different, and this kilometer variable is different from this. Well, it has to be different. I call this kilometers instead of just kilometer up here. I hope that makes sense. I kind of feel like I should stop the video and redo that. I'm going to try that one more time, and hopefully I'll explain this better. So, when I call the function kilometers to miles here, I am passing into it what the user entered in the form of the variable kilometers. When you pass a value into a function, it is called an argument. This argument gets pushed into the, in this case, there's only one, so it gets pushed into the first parameter in the function. So if I enter 5 here, 5 gets pushed into kilometer here as 5, and then we multiply 5 times 0.6214, return that value to the calling function, it outputs, and then the word miles outputs. Hopefully that was a better explanation. When we run this, I'm going to, well, I've been saying 5, so let's enter 5. So 5 kilometers equals 3.10 and a lot of decimal places after that. We can format the results of this function by simply putting the function inside the format function, and we will do we'll use the formatting string comma dot let's actually 1f for one decimal place of precision. Hopefully that will be okay. I don't think I need a continuation character. Alright, we'll enter 5 here, and there we go. And if you take a look at the example that I provide, I did 10 kilometers, which is double what I have here, and if we double 3.1, we will have 6.2. So it looks like it is working as intended. Let's do a quick step through for this one to make sure that we understand what's going on under the hood. So I put a breakpoint on the main function call there. So I'm at the main function call. We step into it or press F11. I go up here, we print out, I go to the main function, we print out the introduction, and that, I don't know why it's all the way over there, but okay. We print out a blank line, or rather, we print out to ask the user for input, and we'll put 10 here. Then we print out the blank line, rather. And now we will output the value the user enters, but we're going to have to jump to the function. And when we execute this statement, we jump up here, kilometers. Notice that the value here is 10. The value there, it's not showing it for me. But it was 10. And when we pass it up here, notice that 10 gets pushed into the parameter kilometer. And we do the calculation, it gets returned. I don't know if we can actually see it. No, we can't see it. We'll have to wait till it outputs. We go back to the main function call, and because there's nothing after that, the program simply terminates. All right, that is exercise number 1. I'm going to do something different on the next exercise. I'm going to create, let me pull this over just a bit more. I'm going to create a file under my chapter 5 here. I'm going to call it prime.py. And I'm going to show you how to create a module. In this case, the module is called prime. And include the module in a separate program and use what we have here. Okay, so exercise 2 says, a prime number is a number that is only evenly divisible by itself in 1. For example, the number 5 is prime because it can only be evenly divided by 1 5. The number 6 is not prime. It can be divided evenly by 1, 2, 3, and 6. So we are going to write a Boolean function in our module here called isPrime. When we create Boolean functions, we usually word them like a question. So isPrime, something like is valid, or has completed, or has finished, in the form of a question, because Boolean functions, just like a Boolean variable itself, a Boolean variable can be true or false. A Boolean function can only return true or false. So it will have one argument. So create a Boolean function named isPrime, which takes an integer as an argument and returns true if the argument is a prime number. If the number is not prime, the function returns false. And we will write a short driver program. I include a hint here related to the modulus operator, because if the modulus operator never returns 0 for a value or a number, then we know that it's prime, because a number will the modulus of a number will only ever be 0 if it can be evenly divided into. So keep that in mind as we write this. So this is going to be my isPrime function module. All right. I told in the directions we're going to call this function isPrime. So let's define, or def isPrime. It's going to accept one argument. I'm going to call that argument value, colon, and I'll go ahead and do my end method. All right, what do I know up front? If I opened a web browser and I want to see what the first 100 prime numbers are, I'm just going to search for that. First 100 prime numbers, and hopefully one of the early hits. Okay, here we go. Notice that the first prime number is 2. 0 and 1 are not considered prime numbers. So what do I know off the bat? Any value less than 2 is not prime. So let's start there. If the value that is passed into this function is less than 2, or it's 1 or 0 or negative values, I can immediately return false, because that number is not prime. Otherwise, or else, this would mean that the number is 2 or greater, which means it has the potential for being prime. Now, let me go ahead and do my end if there. To determine if a number is prime, I am going to have to divide it by every value 1 less than the value that's entered by the user. So think about this. If the user enters, let's say 6, and then 6 is passed as the argument to this function. So I'm testing 6. I want to test it against 5, 4, 3, and 2, the modulus. I know that 1 I don't have to test for. So, because 1 will always evenly go into it. And then according to the directions here, it doesn't matter if 1 evenly divides, because it always will. It's only if 1 and the number. So if the user entered 6, and I'm just going to write this out, the user enters 6, then I want to test 6 mod 5. Of course, that will return 1. Oh, that's not what I want. 6 mod 4 returns 2. 6 mod 3. And at this point, 3 goes into 6 twice, so there's nothing left over. 6 is not a prime number. So at this point, I can immediately return false. There's no need to test 2, because the first time it can be evenly divided, it cannot be a prime number. Let's do the same thing with 7. So with 7, I would want to mod it by 1 less, or 6. So 6 mod 7 is 1. 7 mod 5 is 2. 7 mod 4 is 3. I'm going to copy that one. 7 mod 3 is 1. Goes in twice, leaves 1 left over. 7 mod 2 is, let's see, 1. So it'll go in 3 times and leave 1 left over. And if I get to this point, I know that it has to be a prime number, because all the values that are 1 less, in this case 6, through 2, if I'm going in reverse, which I will be, I know without a shadow of a doubt this number is prime. So that's what we have to do. We have to test 1 less than the value entered, and then 1 less that one, 1 less, until it gets down to 2. Alright? And as long as it doesn't return 0 for the modulus, the number is prime. So let's take this thought and convert it into a Python code. So, for, I'm going to call it counter, or count, in the range of 2, because I want to start at 2, comma, the end range will be the value that the user entered. And this works out great, because if you remember here, this value is not inclusive, which means it would, if the user enters 6 for the value, this would check the range 2 through 5, which is fantastic. That means I don't have to subtract 1. It's already doing it for me. So, if the modulus of if the value mod count, or every iteration of the loop, so we're going to start out at 2. So if 6 mod 2 equals or is equal to 0, then we know the number is not prime, because if it can be evenly divided into, it is not a prime number. And I'm going to do something that I hope is not going to be confusing to you. Let me do N4 there. All right. So let's assume the user entered 6. So the first iteration we start at 2, so count is 2. Or 6 mod 2 will equal 0, in which case we can immediately return false. However, if they enter 7, so count would be 2 the first time, 7 mod 2 is equal to 7 mod 2, 1. So we would go to the next iteration. Count is now 3. Value mod 3 is equal to 1. So we'll go to the next iteration because it's not 0. Value mod 4, or 7 mod 4 is 3, which is not 0. 7 mod 5 is 2. 7 mod 6 is 1, in which case we drop out of the loop, or we have exhausted all of the potential tests. If it makes it through this loop, I can, with assurance, know that the value is a prime number. So if we make it through the gauntlet of tests, I can safely say that the number is prime. So after the loop, if it gets through the loop without returning false, I will return true, because the number has to be prime if it makes it through the gauntlet, if you will. All right. I hope that is a good explanation of this logic. If it's not, rewind and listen to it again. And hopefully that will explain why I'm doing what I'm doing here. All right. I'm going to go back over here and create another Python file. I'm going to call this e2 underscore. We will call this prime number driver.py. Exercise 2. I'm just going to call it prime number function driver. Okay, the first thing that I'm going to do is import my prime .py file. And to do that, I simply do import and then the word prime. I can do this because prime and the file that I'm importing it are in the same folder, so this will be acceptable. If it was in a different folder, I would have to either use an absolute path or a relative path to its location. But because it's in this folder, this will work fine. And I'm not going to do this. I'm not going to ask the user to enter a value here. I'm just going to test it straight away. So let's do, let's create a main function. Main functions don't typically have arguments. They can, but they typically don't. Definitely not in our programs. In method. Let's call the main method. Okay. All right. I'm going to do for number in range, and we'll start out, we'll do 10. Let's see, 10 will return 0 through 9. Let's do 11 to get 0 through 10. And what I'm going to do is I'm going to print the number, comma, and call the prime modules isPrime function that I just created, and pass into it the loop count, or the number. So this should show me through 0. Do keep in mind that by default this returns true and false. So if the number's prime, it will show beside it true. If it's not prime, it will show false. So let's see this in action. All right, 0 is not prime, 1 is not prime, 2 is prime, and that's true, 2 really is prime. 3 is prime, 4 is not prime, 5 is prime, 6 is not prime, 7 is prime, 8, 9, and 10 are not prime. It looks like it's doing what it's supposed to do, and the function is working correctly. Notice when I call the function, because it's housed in the prime module, this file, I have to call prime dot, this is the dot operator, and then I can access the isPrime function, which is part of this file. Now you don't have to do this for this lab coming up, but I just wanted to show you how you would do it. And for the third program, I'm going to create it real quick. And we are going to reuse the prime number function that we created previously. We're going to call this E3 underscore prime number listing.py. All right, let's call it exercise. Oh yeah, I had it right. Exercise 3 prime number listing. All right. Because you don't have to do this in the upcoming lab, I'm actually going to copy this and paste it into this program. I don't have to do this. I could import it just like I did here, but I don't want there to be any confusion here. And so we'll create that. I'll come below here and create the main method. And then we'll do call main method. Remember, our main function or our main method is where our mainline logic goes. Up to this point, we've been putting all that logic in the global scope. We want to now put it in the main function or the main method, so that our code is very modular. All right, let's output the program's purpose first. Print. This program outputs a list of prime numbers that exist in a user specified range. Dot. New line character. All right. And then we ask the user to enter a number. I'm going to call this number. Oh no, I'm sorry. I was looking at the wrong output example. We're on example 3 or exercise 3. Sorry. All right. Okay. So I'm going to call this variable actually start range. And we'll set it equal to the result of the input start range colon space. Be sure to put that space in there. That's good design. This orange, yellow, deep yellow squiggly line means that I'm not using this variable, and that's just a notification to the programmer. We will use it in just a moment. I'm going to create a variable called endRange. Set that equal to the input of endRange colon space. Let's convert the results of these input functions to integer, both of them. We could do some validation here. Make sure that the users, well, truth be told, as long as the user doesn't enter the decimal number, we should be fine. We haven't talked about yet about how to validate if the number entered can be converted to an integer or something else. So we won't worry too much about this, because if the user enters something like -5, it's going to work. And we will, because of how we wrote our isPrime function. All right. And now we're going to output both the number of primes that we found and the number that is prime. So we're right at for loop here. And I'm just going to use count again. You could use counter, something like that. In the range of start range, comma, end range, +1. Otherwise, it will go to 1 less than end range, and we don't want that. Colon, if is prime. And notice that I don't have to do prime.isPrime here because I have the prime function directly in my code. If is prime, passing into is prime the value count. And I could do is equal true, but I don't have to include that because it's assumed by default. So I can just say if the count is prime, then I will print, oh, I got to print the number of prime numbers that I've found. So I'm going to go outside above the for loop and create a variable called total primes and set it equal to 0. And this is going to hold number of primes found. I could also call this primes found, number of primes found, something like that. I'm just going to call it total primes. All right, so I have to increment total primes first. So total primes plus equals 1 if the number is prime. And I will print the number of primes that we found, comma, dot, comma. I'm going to, oh, after that dot, I'm going to put a tab character, followed by the count, or the number that I'm currently on. So if we start at, let's say, 3, then count would be 3 at the start range, and so forth. And comma, I'm going to pass in the separator argument to get no separation here. And that's pretty much all I have to do for that. Finally, I will output, or rather print. Let's start with a new line character. There are, and after that, comma, we'll output the number of prime numbers we found. Prime numbers between, and then we'll output the start range. Comma, the word and, the end range. I'm not going to put the period. We'll just do that. So if we've done this correctly, and we say the example I do 0 and 10. Oh, I need a print right there to get that separation. So right before the for loop, I'll do an empty print statement to get that separation I want. 0, 10. There we go. There are 4 primes between 0 and 10. So basically, it counts and lists the number of prime numbers in a range. That's what this program does, and we can go pretty high here. To save time, let's prove that it works properly. Let's do 10 as the start range and go through 100. So we want to start counting at, I guess it would be 11 would be the first prime. And it is. So it is working between the range. And it looks like there are 21 prime numbers between 10 and 100. We would want to do some validation here to make sure that the end range is not greater than the, or rather the end range is not smaller or lower than the start range. Let's do that validation, because that would be a good validation to have. While end range less than start range, then we will ask the user, we'll tell them the end range must be less than the start range. Oh, no, just period there. And that will be the validation. And let's see that in action. Let's do something like start range of 10, end range of 5. The end range must be less than the start range. Let's do 11. One prime number, 11. And we could also notice that there are one prime number. We could make it so that it has an S if there's more than one prime numbers. Or it probably should have prime numbers. I'm not going to worry about that at this point. But well, we definitely could do that as well. It's a good little program. Regardless of what programming language I'm teaching, I will always have students do an isPrime function. It's just a good program. It's a good algorithm to think through. All right, that will leave okay. Let's do what it says. Let's create a function, a module called random number. So random number.py, and it will create a module called random number. This module shall contain a single function called generate random. All right, def generate random, and it has 2 arguments, min, max. These parameters determine the range in which a random integer shall be generated and returned. All right, so we're going to have to import the random module. Truth be told, we don't necessarily need to do this because the randint function of the random module basically does this. But we will do what it says. We'll return random dot rand int and pass to it min and max. And that's pretty much That's pretty much it. Oh, I'm missing a colon right there. All right, so that's going to be our function for generating random numbers, because I don't want to call random.randint for some reason. I've wrapped the function in another function. All right. We will then write a program that imports and uses the random number.py module. The program shall generate a random number between 1 and 100 and asks the player to guess the number. If the user's guess is higher than the random number, the program shall display too high, try again. If it's lower, will display too low, try again. When the player guesses the random number, display, congratulations, you guessed the number correctly, and then the number of guesses it took. After the game ends, ask the user if they want to play again. All right. So let's create a new file, and we'll call it E4. Oh, that's not an E. E4 underscore I'm going to call it rammed num guess game for brevity's sake. .py. Can't forget the .py. All right, this is exercise 4 random number guessing game. And this is a classic example. Let's create the main function. End method. And we'll go ahead down here and call main method. Notice that I usually do this all at the very beginning. Do I have to create any other functions? I don't have to, according to the instructions. So I probably won't. I could, but I won't. All right. Let's output the program's purpose. Guess a number between 1 and 100. New line character. Oh, there is a period. New line character. All right. Okay, before that, I'm going to create a variable called I'm going to call it target number, and this is going to be the randomly generated number. I'm going to set that equal to, oh, I got to import, what did I call it? Random number? Oh, there it is. So let's do random number dot generate random, and I'm going to pass into it 1 and 100, or at least I will at this very moment. But I'm going to change this because I'm going to create a constant called let's create some constants. I'm going to call it start range, set it equal to 1, and end range, and set it equal to 100. Notice that I'm declaring these constants outside the function, and it's in the global space, which means it's usable by anything in the program. Global constants are acceptable, whereas global variables are not. So these are going to be my global constants. Remember, constants have to be uppercased, where each word is separated by an underscore. So I'm going to change this from 1 to start range, change 100 to end range. All right, how do I want to do this? I can't use a for loop, obviously, because I don't know how many times I'm going to have to loop. Okay. Let's create a variable called number of guesses. Set that equal to 0. That's going to hold number of player guesses. All right. Still deciding how I want to do this. I could let's see. I'm trying to decide if I want to do an infinite loop where I break out programmatically, or if I want to use a while loop that's tested against the target number. And breaking out of the loop would be easier versus testing against the target number. While true. That basically means I have an infinite loop. But I will break out of it when a condition is met inside. While true. And I'm not sure this is the best way. But I think this will be the cleanest way. So let's go for it. Alright, we will print the word guess space. Oh, I hope I can concatenate in the print here. I'll have to check if this will work. And we'll output before that we'll increment number of guesses so that it starts it's at 1. So we'll increment number of guesses, and then after that I don't know if this will work. I need to test this first off, because I'm thinking this might throw an error. Okay, it did. Can only concatenate string, not integer, to string. Alright, let's see if it will allow me to convert number of guesses to string using the string function, or str function. Oh, it did. Good. So that's how I handle that. I had to notice that I didn't pass in these as arguments. Oh, I could. Oh, this isn't a print statement. This has to be an input statement. So that's what I was thinking. So I'm going to call this guess equals not input, or not print, rather input. And I don't know if print's going to allow me to do this. That's what I wanted to test. I don't know if it will. It did let me. Terrific. So notice that I have to concatenate using the, in this, so it's a plus sign. However, in this perspective, in this, what word am I looking for? How it's used here, it's the concatenation operator. All right. Okay, so we get the guess from the user, and then we say if guess, do we do is equal to first? Let's do if guess greater than the target number, or the number that that has been randomly chosen. If guess greater than target number, then we print, looks like there's a tab character at the beginning. It's either tab or a series of spaces, I don't know. So if the guess is too high, then we say Yeah, too high. Try again. If the elif, the guess is less than the target number, we output too low. Try again. And then otherwise, it is right, or we've hit the number correctly. And we output correct. Correct. And in which case, if we are correct, we break out of the loop. And we issue the break command here to, I'll call it break out of the loop. Number of guesses incremented properly. All right. And then we'll go after the loop. Although we could do this in the loop. Do I want to just do that in the loop? There's really no reason not to. Yeah. We'll output correct, put a new line at the end, and then print congratulations, exclamation point. You won in, and then the number of guesses, or yeah, the variable number of guesses, comma, and then the word guesses. And that's all I'm going to test right now. That's all. This is all I want to test right now. Is to make sure that the program does what it's supposed to do. To cheat, I am going to, because I want to know what the number is. Apparently, my mouse wheel is not wanting to work for right now. So I'll put this up there. Let's put our variables together. So we'll put that there. Let's close it so we can see the whole picture. Okay. All right, let's test this program. And just so that I know what the number is, I am going to, right before I print out, I'm going to print out the target number. Just so that I know what it is, so that when I'm testing it, I can, this first time, that I know that it's working properly. All right. My first guess. So the number is 35. That's the target. So let's test 50. Uh-oh. I'm not converting this to an integer. So let's stop. Let's convert the value entered by the user to an integer. And try it again. Alright. So the number's 21 this time. So let's do 50. Oh, it doesn't tab over that far. It's not a tab. It's just spaces. It's a little bit too far over. I'm gonna say it's I'm gonna say it's 3 spaces over. So we'll just put those spaces directly in. Let's keep going. Let's do 50 is too high. Let's do 25. Still too high. Let's do 10. Let's do 20. Let's do 22 and 21. Oh, correct. Supposed to be over 2. Congratulations, you won in 6 guesses. And that was my 6th guess. Though this time, I'm going to take out the printing of the target number and guess it on my own. All right. So my first guess, now there is a logical way of doing this, and that is to use a binary search. Binary search says if the number is between 1 and 100, we start at 50. Okay, it's too high, so we take half of that. So now I search for 25. You should never have to search for like more than 6 or 7 times doing a binary search. 25. It is too low. So now I'm going to go between 25 and 50. Let's say, oh gosh, what is half of, it'll be 12 and a half. So let's go 13, 40, 37? Let's go 37. That's about halfway. Too low. So let's go halfway between 37 and 50. That is 13. So let's do 43. Let's do 43. Or 44. 44 would be 6 down. 44 or 43. We'll do 44. Oh, it's 44. And so yeah, I binary search. It's divide and conquer basically, and you just keep dividing and dividing and dividing by 2 until you get the number. And it shouldn't ever take more than 6 or 7. I forget what it is. 6 or 7 guesses. Let's do it again. Make sure it's not a fluke. All right, we'll start at 50. Too high, so again 25. Too high, so 13. Too low, 19 or 18 or 19, I guess. Too high, so it's between 13 and 19. 16. Yeah. All right, the final aspect of this program is that we have to repeat until the user enters in. So we have to ask them if they want to play again. There's a couple of ways we can do this. One of the easiest ways, and I think what I'm going to do to make this as easy as possible on myself, I'm going to create a function just right here above the main function. And you don't have to do this. We could put it straight into the main function. I'm going to call this function play game, and in method. And I'm going to actually put everything here inside of play game. So that should, and I'm gonna come back and fix this in just a moment. So I'm gonna put all my logic inside of here, and below here I am going to ask the user if they want to play again. So input, I'm going to call this variable play again. Should I call it play again? Yeah, we'll call it play again. Set that equal to the input of, would you like to play again? Question mark, space, uppercase Y, lowercase n, and then a colon and a space. And I'm going to set this to lowercase using the .lower function. I may not have ever shown you that before. But all this does, whatever the user enters here, the .lower function, so if they enter an uppercase y, it will make it a lowercase y. If they enter an uppercase n, it makes it a lowercase n. If play again is equal to if it is equal to y, that means they want to play again, then I'm actually going to make play game a Boolean function where it returns true. That means they want to play again. Yeah, and we might need to validate. Yeah, we probably would want to validate this first. If play again does not equal y, and or play again does not, not if, we would say this will be a while loop. While play again does not equal y, or play again does not equal n, so they didn't enter either y or n, which are acceptable values, we will tell them, please enter y to play again, or n to exit. And then we'll ask them to enter it again. So this is my get and validate if player wants to play again. All right. If they enter, so after this, if play again is equal to y, then we will return true. And I'll show you in a moment how we're going to handle this. Otherwise, return false. They don't want to play again. So I'm going to, and like I said, this is not necessarily the only way to do this. This is one way of doing it. We could have left everything in main and it would have been fine. Let's just show you a slightly different way. If play game and remember that I could put in is equal true, but I don't have to. So if play game I'm not sure this is, let me think. So if play game, oh, not if. I don't know if this will work. I might have to redo this. While play game pass. Woo! I've never done something like this in quite this way. So basically, while play game beginning and in parentheses. All right. I don't know if this is the best way of doing this, but I think it will work. All right. Wow, I don't know if this is going to work. Let's see. All right, so this is game one. All right, let's do 50. Too high, 25. Too high, 13. Too high, 8. Wow. 4. 2. 1. That was 1. All right. Here's the moment of truth. I should have put a new line character in front of that, so I'll finish that now. All right. If I've done this right, and I'm not sure if I have, if I hit N here, the program should terminate because it's going to pass back here while it will be false, and it should stop the program. Oh, please enter Y. Oh. Wait a second. Okay, play again. Oh, not or. It has to be and. The logic gets flipped. This is why I don't use not equals to. Okay, one more time. 50. Too high. 25. Too low. 37. Too low. 44. Too high. 41. Too low. It's either 42 or 43. Alright, there we go. Okay, again, if I enter in here, the program should terminate because when this is evaluated, it would equal false and drop out of the loop. It did. Okay, so that's good news. All right. Okay. So how this works is it might be easier if I put equal true here just so we can see it. So when they finish playing a game, this will return true if they enter Y. So while they play the game or want to play the game, it will continually play. It's only when this becomes false that the program will terminate. So think of that. So just imagine that's in there. So I'm going to try it again, and this time I'm going to play again. 50. Too low. 75. Too low. 87. Too high. 81. Too low. It's between 75 and 81. 78. Too low. It's either 66 or 77. 76 rather. Oh, wait a second. Oh, it's too low, not too high. So it's between. Oh man, I just ruined my score. It's between 81 and 87. 84. It is 84. So when I type in Y, it should output the program's purpose and start all over. Yes. Guess a number between one. First guess, 50. Too low, 75. Too high, 63. Too high. So it's between 50 and 63. 57. Too high. So it's between 50 and 57. 54. So it's either 51, 52, or 53. Let's do 52. Too high. It has to be 51. And this time, I'm going to say, no, I do not want to continue. and the program terminates. Yay! Now, I came up with doing it this way off the top of my head because I wanted to include another function. You could have put all of this logic and left it in the main function. All right. I just thought that this was clever, and it uses pass in a way that's meaningful because this has to be here or it won't run. It may not be the best way of doing it, but it's definitely a way, and I think it's a clever way. So that is exercise 4, random number guessing game. I hope that specifically on this one that you have learned a bit and you can use it in the lab for this week. So that's going to bring this video to an end. As always, if you have questions, feel free to shoot me an email. I hope you have a fantastic rest of the day.